you mentioned single and multiple utility memory, have you discovered a hack of converting these single utility memories into multiple? Like say I have an exam tomorrow. I want to remember the stuff for life, but I just end up forgetting it by the next morning as well. Have you discovered a way? I'm just asking for a hack to convert that single utility memory into multiple utility.
So the interesting thing is that how much of this can be done consciously.
Yeah.
So a simple action that you do all the time, you go to the airport. Well, you are New Yorker, you don't have a car probably, I don't have. But if you do, then I live in New Jersey, you go to the parking lot, you can do two things. One is you take a photograph or write it down. Or if you don't have those things, you look around, right? You actively engage yourself in grounding one thing to other things that are much easier to remember, such as where is north or where is the entrance or something like that. So this is a very well-known way of helping you to memorize things. The more exciting thing, I think, is that how do I know what aspects of our conversations you will remember tomorrow? And we have asked that question from Rodens. He said, what is this called credit assignment issue? What is the thing in the brain that can tell you whether that thing now will be remembered? And we identify the pattern. We call it hippocampal sharp wave ripples. These are short events that last about 100 milliseconds. And we have known from many laboratories, including our laboratories, that many things that we discuss and learn during the day are being replayed in these short, chopped segments of activity during sleep 2,000 to 4,000 times a night. We've got 2,000 to 4,000 times a night of these very short sharp wave ripple patterns. Now, they also occur in the waking brain when you change from what we discussed, the attentive brain, to the non-attentive brain. Attentive brain is associated with hippocampal theta oscillations, but when you shift from there, it said, oh, I found the food, I found the water, oh, I stop my daily activity and I go into sleep, then at that time, there are also sharp waves. Now, it turns out in our hands that particular activity, the sharp wave, whatever it replays, whatever aspects of the conversation is being replayed, that will be repeated thousands of times a night, and that will be the thing that you will remember tomorrow. So the selector is this waking sharp wave ripple. I know this is not what you want to hear, because you are saying, oh, what I decide, somebody decides.
Right. So you cannot consciously originate the sharp wave ripple.
You can't. It's too short.
Got it.
It's too short. But that's the beauty of it, that the brain explains it. And now we can go back and say, why are there sharp wave ripples? And the answer is because there was reinforcement. There was water and food. But water and reinforcement is just an affordance for the brain to switch from one computational state to the other computational state. The mechanism that selects is identifiable by this pattern. And you can say, what is it? By looking around and many other things that you do. But those are very different under different conditions. But the final common denominator that will decide, so to speak, whether something will be worthwhile putting into long-term storage during sleep is this waking sharp wave ripple.